Hello, everyone.
Yeah, it's a long way from the back, sorry about that. Got to use the tech. Okay, so this is all about digitisation. And sorry for the really boring slide to start with just a spreadsheet on it. But I was listening to Phil Winship earlier on, and he was talking about how devolution has affected how we deliver some of our new and innovation related projects, because all the routes and regions are now doing different things. So it was really interesting because this is a snip of the North East route, because I'm the senior engineer for the North East route for Network Rail, and this is our, what I call the mega tracker, affectionately, and this is over 100 lines of digital projects that are in flight. So 100 sounds a lot, but some of them are very small. It might be just introduction of digital rail temperature monitors, for example, but others are the really big stuff that we're working with TA to deliver, such as the 153 inspection train, because we recognise that that's going to be really valuable to our route. And it's useful for me because I recognise I'm an engineer and I know how engineers operate. They're great at starting things, but really, really poor at finishing them. They just like to move on to the next thing and the next thing and the next thing. So this enables me to really understand what's going on and help, particularly with the really big stuff, to get them over the line, get them integrated across the depots and into the nuts and bolts of the North East, if you pardon the pun, and make sure that we get the benefit. We do have a vision. This is my vision for the North East, both in CP7 and into CP8. And the key element to it is really about helping engineers generate a bit of capacity to think more strategically and allow them to solve problems and really start to innovate and create a culture of innovation, particularly in the digital space. In terms of what I'd call condition monitoring, in a continuous sense, the signal engineering community have had this for over 10 years now, and my colleague from Voestalpine quoted a 40% improvement in points failures. Where I worked, when we introduced it, we got 50%, and that's not a boast. It was just that level is resonated in my head. But the most important thing was that it enabled engineers to understand the effect of an intervention on an asset, because quite often we did something and we made it worse, but we'd never realised until you started to monitor stuff. So that was in signalling. We're going over to the track space now, and what I want to do is introduce the same continuous monitoring for my track teams. Not everywhere, but in a very measured way, because it's expensive. So this is where you come in, Petra, to describe what the digital accelerometers, if I can say it, are going to bring us.
Thank you, Ian. So I'm going to talk about KONUX and what we do. KONUX focuses on processing data and artificial intelligence, really. And I know the railway sector is kind of focused on hardware, but it's not only about this device, but what we can do with the data that we collect. And I know that, a note or the mention about artificial intelligence might sound a bit frightening these days to some people. We use machine learning algorithms and AI to process this vast amount of data that we collect. So for S&C condition monitoring, we install these devices on track. And up to this point, we were able to collect 80 million traces, because the device collects basically data from every train that passes through that monitored area. So 80 million traces is a lot of data. So that's why we use machine learning to really search for, let's say, outliers, detect anomalies, and predict how the asset is going to look like in the future. Ian mentioned that we have accelerometers in the device, but it's not only the acceleration that we look at. From acceleration, we derive insights for track maintenance engineers, so they can look into track bed, so void monitoring, how it's going to develop in the next 90 days, but also looking at whether the maintenance they performed was effective or not. So I have some examples in the next slides to show you what we were able to detect and how the users could actually use this data for their maintenance optimization. And looking at acceleration data, from that we can then derive insights about crossing health and blade health as well. So that is also something that we do. The devices are installed at on the bearers next to the crossing nose and at the switch toes. They are IoT devices, so they have they have a battery, but they also have a GSM model with SIM card in it. So basically, it sends data every day to a cloud where it gets processed. And then the data is displayed in our user interface, where basically the users can log in every day and see what changed. The way how we design our system is to make it as easy to read and understand as possible. So basically, when you log in into our system, it rates your monitored asset based on their health. So are they red, are they amber, or are they green, meaning healthy? So this is basically the way how we want to get the data to the end users, so they don't really have to analyze anything for themselves, but it's something that is kind of readily available to use and, draw conclusions from it. Interesting. So what I'm going to talk about next are some insights from an asset on East Coast, and we're going to look at void monitoring and data from maintenance. So basically, maintenance assessment. This asset is, yes, as I said, on East Coast Main Line. It's an E-switch. Line speed there is 125 miles per hour. We have modular concrete bearers there, and well, the reason why it was this site was selected for monitoring was because of costly delays that were caused by voiding. So what you're looking at right now is a graph of vertical displacement or levels of voiding. So that is basically the blue line. The dotted line is a threshold that is set up in the system. Once basically the value is nearing the threshold, it issues an alert to the users, so they know that they should perhaps go in and inspect or plan maintenance. So this site, we monitored it over 1 year. We monitored it over 1 year, and so when we started, that was last year in April, where they did some reballast work right there. So that was basically when it suddenly increased the voiding levels. About a week after, they performed tamping, and they also increased the speed from 50 to 80 miles per hour. So that was basically the dip when machine tamping was performed. But a week after, we had speed restriction lifted back to 125 miles per hour, and you could see that basically the values really sort of skyrocketed, and at that moment the voiding was really, really high. So what they did another additional maintenance really to bring it back, bring it lower, hopefully to its original level before the reballast was performed. But as you can see, basically it was voiding throughout the year. There were some attempts to bring it down, not very effective. But what we can see here is basically our users can put maintenance in the system and see how effective it was. So basically seeing the values, how it was before and how it was, after that. So for example, what you see in the first case, that was lift and pack. Before it was 5.8 millimeters, and basically after 4.8, not really big improvement, and sort of went back where it was after a while. Then there was some manual tamping, stone blowing. Nothing really worked. But then there was another lift and pack that was performed by by a very experienced track supervisor that basically overlifted the crossing. So that allowed it to settle. And what you can see here, before it was 5 millimeters and right after 1.4. So unfortunately, shortly after, they detected a crack at the crossing, so it had to be exchanged after. But basically what I'm trying to say with this slide is that the users can really see impact of their maintenance activities. And then they can basically decide what really works for that particular site, so they can benchmark and understand impact of their actions. Another insight or another case I wanted to mention here is a case of vertical acceleration, because increase in acceleration forces is a sort of a key identifier for issues that are related to welding and grinding, but also half switch and crossing failures. And in this particular case, on the top left corner, you see a graph of vertical acceleration, where you see the sudden increase. That was when they performed welding. And so we notified the users and said, look, there's a sudden change in acceleration. Perhaps you should go and inspect. They went, they painted the rail white, discovered some high spots. And basically this site, back then, it had a really, really stable track bed. But right after, so that was around 1 millimeter. But right after the welding, where the high spots were discovered, we could see that basically this increased acceleration propagated into vertical displacement or voiding levels as well. And it's been voiding ever since. So that is also quite, I would say, strong example of how you can use our data, or in general, any remote condition monitoring data, to understand impact of different maintenance activities. This is another example. Also, so this was a BV1000 weld, where we also detected sudden increase in acceleration. At the moment, what you see on the left, the vertical displacement is still pretty low, 1.2 millimeters, but it will be interesting to see how it develops in the future, and hopefully it won't be the same case like in this graph. So what I'm trying to say here, there's a lot of text, is remote condition monitoring in general provides assurance for engineers. They do know how the asset is doing basically every day when they log into the system. They can understand the degradation level and the pace of the degradation as well, and sort of benchmark and understand those maintenance activities and their impact, which is something they didn't have available really, to see how the asset changed day after they performed maintenance. But what I want to highlight is the compliance bit. So in September this year, there will be a new 054 standard coming into force, which basically says that all S&C need to be monitored for voiding. So this creates quite a significant, let's say, effort for the maintenance team to go on site and measure it, installed void meters, etc. While with remote condition monitoring, you can just simply monitor it remotely. So it does free up quite a lot of capacity for other activities.
Thanks, Petra. Just to echo Petra's point she's made, is it's getting ever more difficult to get people onto the railway, and it's obviously really expensive. There's a premium requirement for on-track machines. So technology like this, and I just must stress, in a measured way, because you wouldn't necessarily fit everything with all these devices, but in the right place, and with the right people, it'll enable you to deliver the right work at the right time, to the right quality. and start delivering a really cost-effective, high-performing asset. The point of this slide here, and I call this the spider diagram, and I don't know why, because it looks nothing like a spider, but this is actually, it's not a KONUX, this is a network rail creation from the Intelligent Infrastructure System. And when we, our journey of over 10 years in the POE space, we introduced hundreds of sensors, and the engineers were getting overwhelmed with data. You know, it was hitting them from everywhere. And these are busy engineers, and this particular suite of points is all around the Sheffield depot. There's about 100 points there. But the algorithms that are associated with the data contained within intelligent infrastructure have been manipulated such that they can detect outliers and points that are just operating unusually. So it enables busy engineers to focus not on 100 points and start to look at individual traces and what's going on here and what's going on over there. Just to say, look, get out and see these 4 enter points in the yellow at the critical locations, because there's something happening there that's unusual. So this approach is critical if we are to cope with the high volumes of data, because it's all very well fitting all these wonderful sensors, but there's a really big risk that we overwhelm our engineers.
Yeah, talking about POE health, it is a key part it is responsible for quite a lot of switch-related delays, as we know. And so what we're trying to do in KONUX is look at S&C as an entire system. It's not only about looking at the data that we're able to provide, but the idea is to bring different kinds of data sources together. So yeah, sure, void measurements, acceleration, but also other sources such as asset details. Really, what is the history of the asset? What are the inspection reports? What was done in the past? What kind of maintenance? But also merging it with data from different suppliers, looking at electric current and train-borne and trolley data measurements. So the idea is for us to create a system where we use different sources of data, and then we're able to detect failures that we would miss without, bringing everything together. So there's an example. This is something that we're still working on. It is a sort of work in progress, but I wanted to show this to you. So each of the dots are basically individual train traces, but the point here is basically we combined data from our device, so displacement and acceleration, information about speed, with electric current data, and with our, let's say, something what we called point machine score or health score. So the idea is when we combine all these different sources together, we would be able to predict, let's say, when point operating equipment is about to fail. So I think that will be it.
Yeah, thanks, Petra. So just to finalise, it's all about the data, to summarise. Yeah, if we're going to move to a direction that is true reliability-centred maintenance, and this is really a shout out to the manufacturers and suppliers, we've got to share our data. We've got an awful lot of discrete data sets, so the machine learning stuff is only good if it's got the data to work with. And the second point is we're overwhelming our engineers with multiple platforms. So please share your data so we can reduce the vast amount of different platforms that we're expecting our busy engineers to use. That's it. Thank you very much.